Hello everyone, welcome back to rkphysicsshiksha. In our class today, we are going to discuss on a special case of friction, so which includes pseudo force as well and friction both together. Here, this concept or a model of question, I just consider it as block on the truck. So in this model, what we consider is we will take a truck on which there is a block placed, and this block is of mass, we'll consider it as m. There is a block placed on the truck and the mass is m, and this truck is moving with uniform acceleration. This truck is moving with an uniform acceleration, and that acceleration I consider it as acceleration of the truck, which is at. Now if the truck starts moving, what are the things that might happen with the block that is there on the rear side of the truck? This is the block, and if this truck starts moving, what are the things that might take place with the block? For example, if you are a person who is on the truck, for example, you are sitting here on the truck, and with respect to you being there on the truck, what things might happen with the block when the truck starts accelerating? There are situations like this. As the truck moves forward, there is one opposing force that will act on the truck not on the truck, between the block and the rear side of the truck, so that force we call it as the frictional force. And with respect to the non-inertial frame, as you are here, there is one more force acting on the block, that is the pseudo force, that is equal to mass into acceleration of the truck. Now based on these things, what we have here is the pseudo force, mass into acceleration of the truck, and the frictional force. Based on these conditions, if the pseudo force, mass into acceleration of the truck, is greater than the frictional force, what frictional force? We have to take it as limiting frictional force. If it is greater than, the block starts moving with an acceleration a. Or if in case the pseudo force is less than or equal to the limiting frictional force, in this case the block will stay at rest with respect to the truck. So what is that force that is making the block to stay at rest? It is the frictional force, and this frictional force is acting in this direction, as you see in the diagram. But if there is one more force here that is making it to oppose its overcome the friction. For example, if this pseudo force is greater than the limiting friction, then the block will start sliding off the truck, because the net force will be in this direction, and it will gain an acceleration which is AB. So for this to happen, or for example, for the block to remain at rest, if you have to consider the situation like this. If the block has to remain at rest on the truck, what should be the maximum acceleration of the truck such that the block will remain at rest with respect to the truck? That means, because here the pseudo force is the one which we are considering here for the situation of non-inertial frame, where it is one which is making the block slide down if it overcomes the limiting frictional force. So what is that maximum acceleration? We'll calculate now. Okay, coming to that, if we take or if we consider the forces that are acting on the mass m, the forces that are acting on the mass m, we consider the gravitational force downwards, mg, and the normal reaction exerted on the mass by the floor of the truck, that is n, I consider. And now, as it is at vertical equilibrium, these two forces are n is equal to mg, we can take it directly, write it as n is equal to mg. Now the first condition I told you that for the body, for the block to be at to be at rest on the truck or with respect to the truck, with respect to the truck, what is the condition here? So for that to happen, I consider the forces acting on it horizontally, that are, one is the pseudo force, which is equal to mass into acceleration of the truck. If F bar is taken, it is minus m into AT bar. F bar is equal to, and there is one frictional force, that is this friction, and I am assuming the coefficients of friction here as mu k as coefficient of kinetic friction, mu s as coefficient of the static friction. Okay, in this situation, if for example, or we consider it like this, the pseudo force is there. So the pseudo force is, the magnitude of the pseudo force is equal to mass into acceleration of the truck, and the frictional force is F. Frictional force is equal to F. This frictional force F will be static friction if the pseudo force is less than the limiting friction. In that case, the friction that we will have between the block and the surface of the truck is static friction, and that static friction F will be equal to the magnitude of the pseudo force, which is equal to mass into acceleration of the truck. And there is one more situation here, where if for example the pseudo force is equal to the limiting friction, if the pseudo force is equal to the limiting friction, then the friction that exists is the maximum static friction, or limiting friction we know, which is the frictional force that exists is FL, which is equal to mu s into n. We take it as FL is equal to mu s into mg. So for the block to remain at rest on the truck, the pseudo force which we are considering should be always less than or equal to mu s mg, or we can first write it as it should be less than or equal to the limiting friction. So in that situation, the pseudo force is, we know that, which is mass into acceleration of the truck, and which should be less than or equal to mu s mg. Now here the m gets cancelled out, so the acceleration of the truck should be less than or equal to mu s into g for the block to remain at rest on the truck. And how much is the maximum value of this acceleration? Maximum acceleration of the truck should be AT maximum is equal to mu s into g. This should be the acceleration of the truck for the block to remain at rest on the truck. Right. Next, if in case the block, as I already told you, there is two situations. If this frictional force is static friction, for which the pseudo force will be less than the limiting friction, and that static friction is called as static friction is equal to the mass into acceleration of the truck itself. So this is one situation where the block is remaining at rest. Now if in case this situation comes right like this. If the pseudo force is greater than the limiting frictional force, if the pseudo force is greater than the limiting frictional force, then what happens is the block starts sliding. The block starts sliding. So if the block starts sliding, it will have some acceleration. In the same situation of the diagram, if the block starts sliding, what happens with the block is, if I consider this as a block on the truck, I just will draw the diagram again. We have this truck, and in this situation the truck is accelerating, and that acceleration is providing the block with enough amount of pseudo force with respect to the truck, so due to which the block starts sliding down the truck. So this is M. Now here the mg as usual will have it downwards and the normal reaction upwards, and there is this friction. If the body starts sliding on the surface due to the force of acceleration of the truck, that is mass into acceleration of the truck, there comes the friction which is kinetic friction when the body starts sliding. And that kinetic friction Fk, here the block starts sliding and the friction is we take it as kinetic friction, and that kinetic friction Fk is equal to mu k into n, where Fk is equal to mu k mg. Now if here this block starts sliding with an acceleration which is acceleration of the block, and how much is this acceleration of the block? How much will be the acceleration of the block? So for that, what is that net force? Net force on the block is equal to mass into acceleration of the truck minus the kinetic frictional force, and according to Newton's second law, what do we have is net force acting on any body is equal to mass of the body into acceleration of the body. So in that case, from these two equations we get mass into acceleration of the truck minus kinetic frictional force is equal to mass into acceleration of the block. Now here I want to calculate the acceleration of the block, and that acceleration of the block AB will be equal to mass into acceleration of the truck minus mu k into g divided by m. So I just wrote the step directly. So the acceleration of the block is equal to acceleration of the truck minus mu k into g. Now this is the acceleration of the block when if it starts sliding off the truck. Right. Now if the distance from the edge of the truck to the block is x, in this case what is the time taken for the block to fall off the truck if x is the distance? So the time taken by the block to fall off the truck will be can be calculated just using the simple equation, which is s is equal to ut plus half at square. And if the time is t seconds, in that case what will I get here? Initially the truck or the block is at rest. Now that x is s, so here I have s is equal to x, u is equal to 0, and a is equal to acceleration of the block, which is equal to acceleration of the truck minus mu k into g, and the time is t. If I consider, then in that case I get x is equal to half into at minus mu k into g into t square, and the time taken will be equal to root of, the 2 goes the other side, will become 2x divided by at minus mu k into g. This is the time taken by the block to fall off the truck. So now the same situation we can also calculate in the same model of the question. They can also ask you to calculate the velocity of the block, at the instant it leaves the truck. So for that case, we simply can use the equations of motion again, which is v square minus u square is equal to 2as. V square minus u square is equal to 2as. And here we know very clearly that u is equal to 0, a is equal to ab, that is the acceleration of the block, which is equal to acceleration of the truck minus mu k into g, and the displacement that it will have is x. So in using that, v square is equal to, I directly write it as 2 into at minus mu k into g into x. So v is equal to root of 2 times of acceleration of the truck minus mu k into g into x. This will become the velocity at the time when the block will fall off the truck. And there is one more question we might get here as well, along with these two also. We will be asked with one more situation where a question can be like this: by the time the block leaves the truck, what distance will the truck travel? What distance will the truck travel? This is one more model in the same model of questions related to this truck and friction and the pseudo force considered. In the same model, they can also ask you this. Means the meantime the block is sliding off the truck, the same time the truck also will be moving forward. In that case, I'll just solve it in this way. So I know, or I'll calculate the distance traveled by the truck as s. So for the truck, consider for truck, s is equal to ut plus, I take it as half at square, or we can simply, we can do the same time. So in this case, we can just take u is equal to 0 for the truck initial starting. So the distance it will travel is s. So s will be equal to half into acceleration of the truck into t square. So the time t is equal to 2s divided by at under the root. Similarly, we already calculated for the block the time t is equal to, we have it as a root of 2x divided by at minus mu k into g. So the time taken for the block to slide off the truck is t. During the same time interval, the truck will move so much distance s. Now from these two equations of time, if I equate them from the above, what we can write is, we get 2s by at, that is acceleration of the truck, is equal to 2x divided by at minus mu k into g. Squaring on both the sides, the roots will get cancelled out, and here the 2 and 2 will get cancelled out, and the displacement or the distance traveled by the truck will be acceleration of the truck into x divided by acceleration of the truck minus mu k into g. So this is the distance traveled by the truck by the time the block will fall off the truck. So these are the different ways they can question you in the case of numericals that you might get on the related to pseudo force, friction, and the truck moving with an acceleration at. With values they'll be provided, you can solve different model of questions on this as well. Hope you understood, and thank you.